Hi everyone, let's try this lesson one more time. So lesson 6, learning about graphic calculator. And this lesson will understand why we need to purchase a graphic calculator because it's really powerful and it's very easy to find answers and you can use it for application questions. And also it's explain why we study math and or relations because there's a many real life applications. So let's look at two examples today. So the first example we have is Lisa purchasing a new car for $20,000. And then through time, car depreciates, right? The value of the car decreases over time. So it's represented by the following equation. Starting from 20,000, you minus 1,250 every year. So every equation will have two variables, x and y. In this context, x is t and y is v. So x is your independent variable, that's t, and your y become v. So in this lesson, we'll learn about how to use the graphic calculator to solve questions. So let's first graph the equation. So go to the graphic calculator, have the graphic calculator with you, and then we enter the equation. 20,000 minus 1250. Now it says t here, but you cannot enter t. This x button next to it, it has t, theta, and n because those are the common variable. But no matter what's the variable, just use x and y. But knowing in this context, what does it mean? X mean time and y, you can only enter y, there's no v, but then y is v here, which represent the value of car in dollars. Okay, so your window should be in the standard, but then when you graph it, you see there's nothing. Why? Because the window is so small, negative 10 to 10. But look at the number you're dealing with. You're working with 20,000. So you need to see at least 20,000. Now, is 20,000 is the value of the car. So is it X or Y? It's Y. So let's go to the window. Okay, so adjusting the window could be the most confusing part. Now go to the window and adjust the window. I like it this way manually because then you know what's going on. But you can also do zoom fit. Okay, zoom 0. Okay, it gives you this. So what's going on? So you look at the window. Wow, they changed the window to this. They didn't change X and then they change Y. That's usually the case. X usually is smaller, but Y can be bigger. Now, looking at the graph, I want to see y-intercept. I see it right in the middle. I want to see the x-intercept. See it, sure, I see it on the edge, but can it be more clear? So I want to see more to the right. So for the window, I'll change x max to 20. Now for y, they give you this window, but I like to see the x-intercept, which means I need to see y equal to 0. So I'll put negative 1,000. You can put negative 10, but this is in the range of 1,000. So I'll just put negative 1,000 to show a little bit of negative on the y. And I'll just keep this the same graph. Here we go. Do you think that's better? Right? You see all the features, x-intercept, x-intercept, y-intercept. In here will be the t-intercept and the v-intercept. And then you see the axis, so you know what's going on, and that's your window. So I'll draw it here. So that's my y max, y min in the magnitude of 1,000. So that's why I put negative thousands here. This is negative 10. I didn't change and go to 20. And then you see a graph is something like that. So this 2 point is the special point on the graph. Once again, a graph is made up of a million points, but then these 2 points are visually special and they have special meaning. All right, let's move on. Let's answer some questions. Okay, so find the t-intercept, which is here, right? Right, t is x-intercept. So how do you find the x-intercept? You need to use the second function trace, which means the calculate menu. Finding which one? Finding 0. Now move to the left of it. It is to the left of it. Enter. Now move to the right of it, so you can keep clicking. Or like this window is 20, right? So just jump to 20. You can enter the number instead of keep clicking the left right button. All right, so I specify left here and I specify right here. Make sure this range include your 0? It does. So then when I hit guess next time, it will give me the answer. Okay, so it will say 0 here, indicating I'm finding the 0, and then 16, 0. Like sometimes this 0 will say like 4e negative 8 or like e negative 4e negative, whenever, which means there's many 0 attached to it. Whenever you see something like this, it just means 0. Okay, so this is my x-intercept or t-intercept in this context. So use the 0 features, and then my t-intercept is 16. Now interpret the meaning. Okay, y represent v equal to 0. This is time, which means 16 years later, the car will have no values. It depreciated to 0. Okay, but you can still drive it. Calculate the v-intercept. V-intercept is the y-intercept. Here, what we know, so just trace 0, you'll find the answer. Trace 0, okay, is 20,000. What does it mean? Interpret the meaning of the v-intercept is the initial value, which means the purchase price. Okay, so every graph, every context, every application question has meaning for those points. Okay, use the trace feature, find out what happened after 5 years. So this is, now, years is time, so you're finding when x is t is 5. Well, if you know t, because it's an independent variable, you can always just trace it. Okay, so you just trace 5. This is finding when time is 5. What's y? Y will be, which means your value is 13750. 5 years later, that's the value of the car. Use the intersect feature to determine when the car will be half the original price. So how many years later the car will depreciate to just half of its price? So how do we do it? Now, if you want to know half of the price, which means 10,000, well, that's the y value. Well, there's no way to enter the y value. You need to do it indirectly, which is you need to enter another line. It says y equal 10,000, so you enter y equal to 10,000. Now you have two equations, and then the answer will be where the intersection is. And then the calculator can help you find out that point by doing something called the intersect, second function calculate, finding intersect. Intersect mean they need two equations. Since you only have two equations, the first curve, they will always find the first one for you, y1. You just hit enter. Second curve, they will just find y2 for you. Just hit enter. So which means you just hit enter, enter, enter. And then that's the answer. Intersection at 8 will give you 10,000, which means time equal x equal 8, which means 8 years later, the car will be half of its price. Determine the appropriate domain and range for this function. The domain, so if you talk about the value of the car only have values from the initial time to 16 years. Okay? It's a continuous data, so I write x in the set of all real numbers. The range, which means the value of the car. The value of the car can go from 0 value to 20,000. Again, you can take on any values in between. So that's the domain and range for the context of this question. All right, let's move on to see another example. Okay, I'll aim to finish this exercise in 15 minutes. All right, another question is you have a human cannonball, and then it's described by this formula, which means you shoot somebody out, and then you place a mat in where the man will land. All right, so it would be a parabola when you shoot something. So take out your calculator. First thing is you clear all your equation, okay, and then you type this equation in: 12 plus 6t minus t squared. Remember, you can only enter x. And then your window always just set to standard first. All right, this is my graph. Okay, I want to see more to the top, so I want to see y max, so you change it. All right, you can try 20 and 30, and I think only 40 works, so you just keep trying, try and error. Now I see the top, perfect. Now I don't need it so much on the left hand side, so you can change the x min to a little bit smaller. Let's say just -2. Okay, just see a little bit more. Okay, all right. So -2 to 10, -10 to 40, and then you see something like that. Now for parabola, what are the special points? They have the y-intercept, x-intercept, and also the maximum point. All right, the graph calculator, use the window, we show it already. Sketch it, we did. What's the height of the cannonball above the ground? Okay, which means initially, at first, okay? So at first you have a cannon here, and then you shoot someone, and then he land there. So this is the picture, okay? So how high is it? It's asking for the y-intercept or the h-intercept, which is h and t, okay? So trace 0. Now you should know how to find the y-intercept. Is 12. So initially, it's 12. What's the units? Minutes. Meters. 12 meters above the ground. Okay, so that's trace 0. Number 2, what's the maximum height? Okay, are we looking for x or y? Well, height is h. It's looking for y. So which means we're looking for this point, and then we wonder how high is it. So when you shoot the person now, how high will he reach? So let's use the calculator to find out this maximum point. It's right here in the middle. So when you find the second function calculate, they can find you the maximum. Make sure you're to the left of it. You are to the left of it. Make sure you're to the right of it. I see some students just stop on the top. No, don't do that. So move all the way to the right. Make sure you're on the downhill side here, and then you hit enter. And then they will give you the maximum point. Now, this 2.999 essentially just means 3. Just read 2 decimal places, round it up. It's perfectly 321. Okay? So the maximum point is 321. Now let's interpret. This is x and y. In this context, this is t and h. So what is this question asking? The maximum height. So should you return x or y? You should return h. So the cannonball will reach the height of 21 meters. Now let's see this. How about the value of 3? Well, that's the next question. How many seconds later does it take the cannonball or the man to reach the highest point? It's asking how many seconds. It's asking for the time. So it's asking for the x value of this maximum point. Every point have 2 values, x and y. Interpret the meaning of them and answer the question correctly. So 3 seconds later, it will reach that point. To the nearest hundredth of a second, how long does it take for the candle to land on the mat? Where's the mat? The mat is here, which means when it hit the ground. The ground is when the height is 0. Well, when the height is 0, which means it's the t-intercept, we're looking for the x-intercept of the graph. So go back to our calculator. And then now I'm looking for this point. So second function, calculate 0. Looking for the x-intercept, I'm ready to the left bound, enter. Let's move to the right bound. You can keep moving or just type the number 10, right? Just jump to the end and then you just hit enter. The answer is 7.58 and then y is 0. Okay, so this point is 7.580. Remember, this means t, this means height. So how many seconds nearest hundredth, which means 2 decimal places, will he land on the mat? The answer is 2.58 seconds later. He will land on the mat. All right, so let's answer the last question here. All right, how high is 1 second after the launch? Okay, so you just need to trace 1. So in the calculator, trace 1. The answer is 17 meters. Well, 1 will be at the same height again, so you need to draw another line, right? Draw another line at 17. And then you see that you find the intersection. All right, we already know the first point. Move it to the second point. Enter, enter, enter. 5 seconds later, Okay, so at 1 second he will be at 17, 5 seconds later he will be also at 17.